Hey world! Today let's talk about batteries. You see I have a bunch of batteries here. Let's start talking about them. You see, this is a dry cell battery. This is used in clocks, toys, and most people would recognize this. Although it's been beat up very bad and it doesn't have any power anymore. I'm just trying to demonstrate something that what a battery essentially is. It is something like a reservoir. It has some chemicals inside, and the chemicals cause a chemical reaction that causes a potential difference of a voltage and creates a voltage on two sides. Let's say there is a lot of electrons on one side and the other side is empty. Think of it like that. It isn't actually like that. Well, it is kind of like that, but not really. And if you connect one end with the other, then the balance would start appearing, or the equilibrium would start to happen. It's more like those electrons would flow back to the empty side and create an equilibrium. How that works is like, think of this as a reservoir where you have a wall in the middle and a lot of water on one side and empty tank on one side. What would happen, do you think, if you were to connect this part with a slim nozzle to a pipe with the other empty side? The water pressure on this side would definitely pump water back to here until it becomes it gets an equilibrium level, that level. Then there would be water all around here and no water here. I hope you get it. That's how every battery essentially works. When you recharge them, what happens is you're using some power like a motor to pump all those back here and create an artificial pressure. That is what we call voltage difference or potential difference in voltage. So I hope you understand. This is a AA battery. There are other types of batteries. You have AA in alkalines. These are alkaline battery. They have about few times more capacity, and also they're quite rigid. They're not dry inside. These are dry inside, but these are wet. If you were to pop one of these, alkaline would leak out and it would probably burn your skin, who knows. And then these are also very common. These are rechargeable. All the early other ones, these two, and also these 9-volt and these, they're not rechargeable. But this is a lithium-ion battery. And what lithium-ion batteries, they use lithium, which is a material that can lose a lot of electrons. It has the potential to lose a lot of electrons, and they have a discrete sheet rolled up inside. These are the same batteries that Tesla used in his cars. Not the same, but the same form factor and the same type of battery. Tesla has their own batteries and they're quite good. And then there is the 9-volt battery. Everybody, I think a lot of people would recognize this. The 9-volt battery is used in multimeters, some music equipments, and many other things. This I brought for the multimeter, but I don't use it anymore, so I'm just showing this to you. Then this is another kind of lithium battery. Basically you would recognize this as a mobile battery, except for this part. Yes, mobile batteries are lithium ion, and these are rechargeable too. And then you also have coin cells. This is a coin cell. You also may have seen button cells. They're even smaller. They're tiny. This is a coin cell. It looks like a coin. This can supply 3-volt. And there are other kinds of batteries for which I don't have an example. For example, sealed lead acid batteries or lithium ceramic batteries, and many other types of batteries. Let's see what a battery can do. Here I have a setup where you can see I have connected a switch, an LED, and a resistor to a breadboard. So if I put some voltage around this onto these two terminals, I would get the LED to turn on at the press of a button. So here I have a battery holder. I'll put this battery in the holder and I'll simply plug the positive to the LED's positive, which is this one, so it would go through the resistor, because otherwise the LED will be burned. The LED cannot tolerate more than 3 volt. So in order to limit the current, we use a resistor, and this is a 220 ohm resistor, not that big, good enough for the LED. It's called an LED resistor. And here I connect this, and the negative terminal is connected to the switch. I can always put the switch somewhere here, but who cares. So at the press of a button, we get light. Now what would happen if I were to directly connect this to the LED? The LED would die. As that would be a good demonstration, I will do that sometime. For now, you may understand batteries. Some other things that very basic things, if you, in case you didn't know about batteries, are that they always have a positive terminal and a negative terminal, and the electron goes from the negative terminal to the positive terminal. I think that's the conventional current flow. I'm not sure, but basically you shouldn't mix them up. You should always know that batteries have a positive terminal and a negative terminal, and they have a limited capacity, and they can be rechargeable or non-rechargeable. They can be hazardous, like this one. If you poke this, it might explode. And they can be safe, like this one. This is a dry cell, it doesn't explode, it doesn't do anything, it's not that chemically harmful. But well, that's as far as I know, so see you.